Okay. All right. It's all you, Gwen.
So we're pleased today to welcome Brian. He's a PhD student at The Ohio State University in the School of Environment and Natural Resources, and he earned his master's in energy and environmental policy from the University of Delaware in 2020, with a final project that was focused on the social barrier to nuclear energy. At Ohio State, he has worked on projects focused on the coal transition's impact in Ohio's communities, as well as a project partnered with US EUCOM on the Department of Defense's potential use of micronuclear reactors. His current planned research is focused on if emerging nuclear technology can address the social barrier to nuclear energy. So we're happy to have Brian sharing with us today some updates on nuclear energy at Crossroads.
Thanks, Gwen. I'll go and share. But yeah, my name's Brian. My presentation is on nuclear energy at Crossroads. Nuclear is in this weird spot where it has this long history that's very prevalent in everyone's mind, but the future outlook seems very different, but whether it can kind of reach that potential, it's just at this weird point. Next, I had an introduction, but that was Gwen did a great job, so thanks again on that. Basically just where we're going, what are the issues facing nuclear, and what opportunities are there. So why are we talking about it? So the International Energy Agency states that the world needs to double nuclear generation by 2050 to meet climate goals. This is actually one of the lower numbers. There's other kind of pro-nuclear academics that said it has to be sometimes 3 or 4 times high, but I usually go with IEA as like, this is the goal to double it. But then the problem is here in the US, we're facing this mass decommissioning between 2030 and 2040. Most of these plants were built in the 70s or late 60s. So they're just coming to their regular end of life. So far, most of the bigger plants have been extended. Browns Ferry in, I believe they're either Mississippi or Alabama. I know Peach Bottom in PA have been extended. Davis-Besse extended. And there's usually a lot of bipartisan support for these extensions because, Republicans want to keep the jobs, Democrats want to keep, emission numbers low, and, nuclear gives a lot of power, but no emissions. But usually this only goes to extending the life of these plants and rarely into like new development projects. And I have this from our world and data that shows, what are the safest and cleanest energy sources. Nuclear down here as one of the safest, and most of those coming from the kind of more famous accidents, but also one of the lowest greenhouse gas emitters, even beating wind and solar on that. So if we're at this point of, we need more nuclear and it's, clean and relatively safe compared to the current pathways, what are the issues? Well, I think we all kind of know the technical drawbacks. This was actually, I almost omitted this because like people know the downside of nuclear energy. So I'll start with the accidents. 3 Mile Island in PA was a partial meltdown, and then famously Chernobyl in the USSR during the 80s and Fukushima in Japan. This is just a little over a decade ago in 2011. And to switch back to how that has this kind of like low death number, that is true. Very few people died in any of these 3 accidents, but they have a much larger impact. They still can't do much around Chernobyl because that one was like significantly just mismanaged. Fukushima, there are people living around Fukushima, but it's still, a lot of it looks like this picture here. And a whole lot of money and effort goes into making these places kind of livable again. So while they are low death, they are high impact when there is an accident. Waste is another big issue. We currently don't have in the US a great way to handle waste. Usually it's just stored by the nuclear facilities. And again, these waste is going to live on for hundreds of thousands of years in some cases. And not to mention all the kind of toxic problems that come along with waste and handling waste and the fear of transporting waste. The nuclear weapons aspect of it is still a big fear in people's mind. That again becoming prevalent again with the Russia-Ukraine war going on. And beyond these kind of health and safety things, they have a very, very high capital cost traditionally and very, very long construction timelines. And I'll touch on some of those kind of figures in a second. just kind of going into the current state of where we are in the US. There are 55 plants. You see most of them here in the Eastern US, 93 total reactors. There's 2 more that are supposed to go online in 2023. And in terms of, cost and timeline, these 2 plants were approved and started, going towards construction in 2007. And now we're at this kind of 16-year point where they're supposed to open in January 2023. And the kind of cost for these 2 reactors is estimated to be around 30 billion when all is said and done in 2023. So there is very high cost, very long timelines for these kind of more traditional reactors as we think of them now. And again, the 2 plants here in Ohio, both along Lake Erie, Davis-Besse, which is in Ottawa County, I think it's like 25 to 30 miles east of Toledo, and then Perry in Lake County, which I think is between 35 and 40 east of Columbus. And that's kind of where nuclear is. And when we think of and conceive of nuclear, that's what we think of, these massive reactors and cooling towers. But the future of nuclear is trending a lot more towards these small module reactors, much smaller, usually around like 300 megawatts. There's even, it's kind of moved towards micro reactors, which are between 1 and 10 megawatts. And some of these can actually get very, very small. So, one of the ones we'll talk about is able to fit on, in a shipping container. Some of them can be put on the back of a truck and drove around. And the idea behind small modular reactors is by making them smaller, there's less going in, means less coming out, less risk all around, and then less cost. I don't think I have this actual there. There's one company that says a small modular reactor should take around 500 days to be constructed. So the timeline becomes much, much shorter. And these are kind of the bigger kind of small modular reactor pathways into these various different fuels. So this first one, halo and triso fuels. Halo is a more general term for high assay, low enriched uranium. So basically uranium that's enriched, but not to the level that is weapons grade. So whatever's made isn't, if you take a bit out, you can't make a weapon from it. Triso is the most furthest along and most popular, and it'll be the one that when I talk about, uranium fuels being used in any of these reactors or these companies, they're using triso. Thorium is where a bulk of my research is centered around. Thorium's another radioactive material, another nuclear fuel. It is very, very cheap. I did this comparison in 2020 that to generate a terawatt hour of power with uranium, it costs $1.5 million. Do the same thing with thorium will cost around $30,000, and that would be like a high mark. They all project the number would go down as there's more of a market to it. Thorium's also what's called fertile, not fissile. So nuclear energy, just a brief thing. Atom splits, those atom splits hit other atoms. And as that chain reaction happens and generates heat, that's what energy comes from. Thorium doesn't split on its own. So there's no real weapons potential there. You need something else to hit it, another uranium atom to hit it first. So I know there's at least one company that's advertising their thorium reactor as a waste reprocessor. Very little energy or very little material has to come in, very little material has to come out the other way. And it's usually the timeline for the waste is significantly shorter. Thorium waste that comes out of a thorium reactor would be about 300 years compared to current uranium, which is around 100,000 years. And plutonium-235 is a different element. Again, is not a weapons potential element, and I'll talk about it a little more when I get down into these radioisotope power systems. But the big kind of advancements are these kind of reactor technologies. Molten salt is the general one. I'll go into molten salt in kind of a little more detail in a second because I have one on a diagram on the next slide. Basically, instead of having solid fuel, they have kind of a pebble mix of fuel, superheated, becomes molten, and that's how the energy happens. High temperature gas reactors, they take these triso elements that are usually like kind of these kernels that are they big. The diagrams I've seen is they put them in kind of like an egg carton thing, and they're more kind of, I'm not 100% on how the gas reactors work. Molten salt's more my bread and butter, but very low risk. Another thing that's kind of meltdown proof from everything we heard of the people working on them with when we talk to the different DoD projects. Liquid thorium fluoride reactors, or lifters, that's a molten salt reactor, but with thorium. You can't just kind of chuck thorium into like a regular one that's used for TRISO. It doesn't kind of work that way. Radio isotope power systems, or RPS, are super interesting. They take just kind of like a lump of plutonium-235. As the plutonium decays, it generates heat that you then use heat capture, and that's what generates the energy. Right now, there's small level. They're talking about ways to scale it up. But one of the interesting things about this is because it generates energy from the heat from the decay. When it's done, there's literally no waste. There's just nothing left there. Well, there's stuff doesn't disappear into nothing, but it's no longer radioactive. And these are kind of some of the current companies and projects. TerraPower's one of the big ones. They are molten salt using TRISO. They're building a plant currently in Kemmerer, Wyoming. They're backed by Bill Gates and Warren Buffett. X Energy is an interesting company. They're doing a high temperature gas reactor. They are currently building a kind of demo reactor. There's around, or a demo set. It's 4 80 megawatt reactors that'll be one, and I think it ends up was at 320 megawatts in the Tri-City region of Washington. But they have another area set aside for when it's successful. That'll be an 1100 megawatt facility in that same area. Eielson Air Force Base in Alaska, I can't find the type of reactor. I see speculation of what it is. Even when I was talking to other military people, they didn't know exactly what was going in. If I had to guess, it would be either BWXT or X Energy, because they're the ones who got other military contracts. But it's a micro reactor that's going to help supplement their current coal facility with the aim to eventually fully replacing it. The DoD has Project Pele, which is micro reactors that they want to use to establish forward operating bases. So the example we kind of always use were like they wanted to put an airfield in Poland during the Russia-Ukraine conflict. Instead of trucking in gallons and gallons and gallons of fuel to power generators, bring in a small micro reactor and not power anything. Recently, BWX and X Energy combined are combining for this kind of use of land in Oak Ridge, Tennessee. TVA has a number of nuclear facilities under their watch, under their authority already. Flive, they do lifters. They are projecting to be commercial by 2030 and are aiming to hopefully get one of their reactors to power a military base, a stationary military base. Think Wright Pat, something like that. And then Xenopower, they do the radioisotope power systems. And here's a brief breakdown of like the old versus the new. And again, I'm a social scientist, not a nuclear physicist, so this is going to be fairly high level. But basically, there'll be solid fuel rods here. These control rods will help determine how much fission there is, basically how hot they get. That heats the water. That then creates steam that spins the turbine. With these pressurized water reactors or boiling water reactors, I believe Perry is pressurized, Davis-Besse is boiler, or it's flipped. They both have to pressurize water. The water has to be kept around between 250 degrees Celsius or 275 degrees Celsius to try and keep the rods cool. And that's where kind of a lot of the size and the safety stuff comes in, is keeping the water pressurized, keeping everything safe, as compared to a molten salt reactor, where basically you'd put those either little like the thorium balls or the TRISO kernels in with a mixture of different salts and other kind of pebbles that is then superheated. And then this molten fuel gets hot enough and the reaction all happens in there. One of the big drawbacks of solid fuel is they are solid, so they take damage during the kind of generating process. So these solid fuel rods would have to be taken out while only about a third of the energy life is used up. So basically when because of the risk of them breaking and then kind of having this runaway fission, they're kind of taken out well before they're used up. Whereas in a molten salt reactor, they'd be able to be used up completely. And the other big kind of positive of molten salt is this thing down here, if you follow my mouse, this freeze valve. So before molten salt would get to the point of, say, a possible meltdown or a possible problem, this valve here would literally melt away, and all the innards would come down to this holding tank where the reaction would then stop and then everything would solidify. Basically, it makes molten salt reactors what they call walk-away safe. So basically, if everyone left, it still wouldn't melt down the way we see meltdowns in, say, like Chernobyl or Fukushima. So barriers in development. It is still a developing technology, so I'm going to bounce back real fast to these. So at Kemmerer, X Energy, Eielson, these are all kind of like they're coming in, they're dipping their toes in it with the plan to go bigger. Same thing here at in Oak Ridge, where they want to make sure everything works. There's a lot, because of all the safety and security and issues, that they're still developing. I know thorium has issues as well, like technical issues, basically, of how things separate and how the fission happens. So it's still being researched. The scalability of some of these things, especially when you look at, say, the RPS systems, or how many small modular reactors you'd have to build up to kind of meet certain things. 1 second. Bureaucratic, it's a long process to like apply to be, you know, just the licenses and all these things. You know, you're seeing articles from like 2021 is like, this company plans to apply for their license for this new type of reactor in 2024. So it is very long term in the application process. They're still developing the regulation apparatus for these new reactors. You know, the NRC is good at regulating boiling water reactors, pressurized water reactors. When you get into the molten salt and the kind of the gas cooled ones, it gets a little, they just have to kind of discover it. And also that process for applying costs like, I believe it costs $1 million. So if you're, say, TerraPower and backed by Gates and Buffett, not as much of an issue. If you're backed by the DoD, not as much of an issue. For companies like Flybe, which are fairly smaller startups, you know, $1 million just to get someone to come out there and look at it and be like, we don't fully know how to regulate this yet, is an issue. And there is this lack of like political will to drive new projects. That has slightly changed a little bit over the past couple of years compared to when I first started researching this in 2019, but still isn't a whole lot of political oomph behind new nuclear development. And one of the big reasons for that is this social barrier of high risk perception, lack of trust, negative narratives. I'm going to try and go through the part kind of fast because I get bogged down going over my whole master's thesis. But the high risk perception comes from the fact that nuclear plants are unique, nuclear accidents and waste are more unique. You don't have a lot of control over what happens at a nuclear plant, and there's a lot of uncertainty in terms of how information gets out because of the secrecy around nuclear in general. Media messages and social media messages amplify kind of any kind of negative. The example I give is I'm from Delaware, just outside of Philadelphia. There was a huge gas refinery explosion 3-4 years ago. And it was, you know, a story for one day and then a meme on day 2, and then it's kind of forgotten about, whereas Fukushima leads the news for a week. So that makes it seem much more riskier. And along with the kind of overlapping risks of, you know, waste and meltdowns and all these things kind of stacking on top of each other. Trust, you have the kind of lack of trust in science that's kind of across society that has not been helped by the pandemic. Lack of trust in government institutions, and especially nuclear institutions have just not been great at communicating for nuclear, and science communication in general is not tremendous. And we can see issues of that coming from how issues around COVID were communicated. Science communication isn't that strong, and it leads to more of a breakdown of trust. There's also a need for secrecy given the current nuclear establishment, because there is still a lot of national security implications to the waste and what happens there. And that also, that need for security or secrecy and security leads to like a lack of stakeholder engagement or meaningful stakeholder engagement. At the most recent plant to come online in 2016 in Watts Bar, Tennessee, or the plant's Watts Bar, I forget the exact name of the town, but we talked to one of the, I talked to one of the local people there, and they're like, we were brought in and they talked to us, but it wasn't really, they weren't listening to us, they weren't engaging. They'd explain things of what was going on at the plant when they were still building it, but not, you know, engaging in a meaningful way. And then you also get these negative narratives about it being dangerous or being high cost. Those also have an element of truth. You get the kind of nuclear as this original enemy in environmentalism. So one of the reasons why nuclear is still kind of a big bad in terms of environmentalist circles is that as the environmental movement grew, it was one of the major kind of enemies. And now as climate change has kind of evolved to be the big bad of environmentalism, nuclear still has this kind of negative connotation. So it's not like nuclear is going to help fight this thing. Nuclear is just also this bad. There's this thing called the propaganda problem. This was coined by actually an anti-nuclear scientist or anti-nuclear researcher, policy researcher, about how because there's all this negative connotation with nuclear energy, anything that's mentioned positive isn't seen as actual factual material. It's just seen as propaganda for nuclear. Kind of my favorite like propaganda point is that a nuclear plant actually is less radioactive than a coal plant, is because of the trace amounts of uranium, thorium in coal that's burned away and then kind of lands around. But it's something, if someone told you that, you'd be like, this one's trying to pull something over on me. And again, this kind of like combative discourse. I had another slide here that was an article that's like, oh, nuclear energy actually hurts meeting climate change goals because countries that invest in nuclear, don't get any closer to their, reducing CO2 emissions compared to countries that invest in renewables, which is, if you look at like nuclear technology that's still developing versus, you're going into research versus if you're funding renewables, you're putting down solar panels. On the pro-nuclear side, there is this kind of antagonism towards renewables, and I'm still very pro-renewables, but also pro-nuclear as well. Or you get the kind of like devil's bargain of like, well, we have to, it's the lesser of two evils, which doesn't really change people's minds. It might get some sway in some policy, regions, but in terms of reaching the public, not really. And during the kind of result of my master's thesis is that nuclear, as it stands now, can't overcome the social barrier, but potentially new technology offers these opportunities to basically overcome these barriers. And the main way to do that is by engaging fast and slow thinking. Daniel Kahneman's ideas of fast thinking, of using heuristics to just kind of like the shortcuts, mental shortcuts, and slow thinking. So to address fast thinking, most companies are already avoiding using the word nuclear. So TerraPower refers to their power as natrium, which is another, I believe, the Latin word for salt. Fly doesn't say nuclear anywhere. So they know that changing terminology will hopefully help, especially on the heuristic level of, when you hear nuclear, you associate it with badness, where if you hear thorium, you're not going to think of Chernobyl. If you hear triso, you're not going to think of Hiroshima. And these new technologies won't have the same amplified risk and all these things of this longer, greater history. And because they are safer, none of these new technologies really have weapons potential. The waste won't have weapons potential. So you can get less secrecy and more meaningful stakeholder engagement. And in terms of slow thinking, so this goes into the project I worked with my other team at Ohio State, working with European Command for this DoD project of, their goal was they have these, or are planning to have these micro reactors that they want to use to power these bases, but not every country wants nuclear within their borders, especially if it's another power coming in, bringing in this nuclear reactor. So the goal was to then kind of create this tool for European Command to use to negotiate with these countries to allow them to use these reactors, specifically to help overcome these social barriers. And there's three major points. These are either come from conflict resolution or decision-making stuff, joint fact-finding, where basically both sides come together and they look up the facts, narrative exchange of getting emotions, kind of infusing them with the kind of more raw data, and then a decision matrix to kind of tie both those things together that in theory should solve the social barrier. I know UCOM is going to at some point do a tabletop exercise to test effectiveness. This will be included as part of my dissertation. So maybe in 3 years, we'll know this does or does not work. And and then future outlook for both Ohio and around the globe. So the two current plants, you guys probably know, extended by House Bill 6, so that creates this major controversy around nuclear. We also have House Bill 52, which I know there are, I think, 10 counties already that have blocked some level of renewable development. Blocking of this renewable development could open the door for what do you call it, for nuclear and especially small modular reactors. Biden's climate bill does have some funding for small modular reactors, but I don't know the level and I don't know what it's going to, and I couldn't find out. I could barely confirm this is there. I saw it and had to look up other places just to confirm where it is. I think one of the things that makes Ohio very interesting is nuclear plants as potential replacement for coal plants. The project we worked on before the coal community transitions, one of the plants was the R.E. Berger plant in Belmont County. And there was talk at some point of that being a nuclear plant, but the more older traditional nuclear plant. That fell through. But if you look at where TerraPower is in Camera, Wyoming, that's replacing a coal plant. The TVA partnering in Oak Ridge is to replace that's been left behind by coal plant closures. Eielson Air Force Base is trying to replace their coal plant. So there's already this plan for a lot of kind of coal replacements. And in Ohio, we're going to see the last remaining coal plants be decommissioned by 2030. And also, don't forget, if you're interested in the coal transition in Ohio, to check out Farewell Transmission at Hopkins Hall at OSU now through September 16th. And don't forget to pick up your cool souvenir postcard celebrating Ohio's coal history. Yay! But that's a fun opportunity for nuclear in Ohio. And then around the globe, the war in Ukraine's affecting a lot of opinions kind of both ways. At the start of the war, it was, see, this is why we need more nuclear because we're dependent on Russian gas. And now, as we're seeing Russia potentially targeting nuclear plants, kind of going the other way. The US is backing small modular reactor projects in Europe. They're currently helping to fund, as of July, so very recent, a new development project in Romania, but plans to go to other developing countries in Europe. China's full steam ahead with all the kind of new advanced reactors. They're trying to get, I believe, carbon neutral by 2060, but they have already in development looking to kind of be ready in commercial fairly soon. Thorium reactors, molten salt, TRISO reactors, gas-cooled reactors, kind of going on everything. Japan is recently, at the start of this year, partnered with TerraPower, and I think are moving forward with that partnership. I know there was some movement on that recently. Japan's also very interesting because obviously they're very complex history with nuclear, with the bombings and Fukushima, but also given both their land use, their geography on an island, they really don't have a lot of fossil fuels. It's very difficult to get large scale renewables. So nuclear's they keep kind of circling back even with all their complex problems with nuclear. And India is making a very big push for thorium. India is rapidly developing. They don't have a lot of energy sources, but they have a lot of thorium. So they're really kind of banking on that one being, banking on the development into thorium. And that is my presentation. Any questions? And I can stop share.
Thank you, Brian.
Oh, and I went long, sorry.
No, that was really good. You're right on time. I guess questions for Brian, if you don't mind. I would like to start with one. You were showing a map of the different nuclear facilities in the country. So what's the site requirements to build a nuclear power plant? I guess I know it probably depends a little bit on what type, but we didn't see any in the northern Midwest, like in Idaho, and not Idaho, but North Dakota, South Dakota, that area. I was just kind of curious why. So
in some, it's the need for water. Basically all of them need a pretty healthy supply of water. Two is a lot of them like the large energy demand, because there were a lot of projects, especially in the Tennessee Valley, that I know that they were being built, and then during the 80s there just wasn't the energy demand, and it kind of closed them out. So that could be another thing. I know both those in especially, you know, North Dakota, South Dakota are big into fossil fuels, so there's probably a greater demand there to keep that going. In terms of like land, they have to be fairly far away from population centers. Right now, how they've been, they have a very large footprint. I think I don't know the exact number, but you have to have a large footprint for it, and then a larger gap between that and like where the nearest population is, and then that's even further rural. But I remember when I was looking at that map, like the first time, wondering why there just isn't a lot of stuff out west or out north. A lot of it's like, what I heard back from experts was like, either they don't have, you know, the water there to support it, or they don't have the population for energy demand, or they demand for other energy in various places. Like I know that was a big problem with, like, we were talking, I can't remember, this is like 2019, there was a nuclear expert I was talking to, it's like, why there isn't a lot in California, and they're like, well, there isn't the water A, and there isn't demand B, or the social demand. There is the energy demand, but not the social demand for it.
Okay, thank you. All right, other questions for Brian? I'm sure you get some questions.
I got a question for Brian.
Oh no.
So I've seen like these, you know, in theory, like these small modular reactors, like you could put it in a city, you could put it in a neighborhood. You could power, you know, the city of Columbus with a couple of shipping containers that are spread around the city. Is that a realistic scenario?
In terms of safety, yes, especially when you look at like the small the molten salt reactors, which are peak safety, that you could in theory put one under, you know, put it under the shoe, and it could power all of Columbus and be just as safe. I feel like the issue there more comes from what people want and what people expect. So there's like, if it was me and just me making a decision, they're like, all right, we're gonna go put, you know, this shipping container in, you know, the overflow parking lot at your apartment, I'd be like, yeah, sure, but I'm not the only person making that decision. Or like burying them. I think you'll see them slowly creep closer and closer to civilization with the these new advancements when they become more accepted. I think that's the big problem now, is that there's always going to be some level of please keep this far away. One positive they will have going is they don't have a big a large iconography. They don't have, say, the large cooling towers that symbol nuclear. They'll be very low profile, so they'll be hard to see. So let's say so I'm in Columbus, let's say they put one in New Albany or whatever, and there might be a pushback at some point, but once it's there for a while, people will be like, we don't even notice this thing is here. You know, there's no way to recognize it. And then we'll probably see it creep closer and closer because they're small, they're low profile. And when people are more used to it, they're more accepting. There is literature showing that if you are closer to a nuclear facility, including like the Davis Bessies and the Perry, the one with the big cooling towers, you become more aware of it and you have like a lower risk perception of it. So they can, in theory, be fine safety wise, but whether people accept it is another story.
And I guess I had another question. Internationally, you know, we're talking about traditional nuclear power plants and the capacity to make weapons. I guess maybe you did touch on this and I just didn't catch it. With the newer technologies, you said, I think you might have said something about that decreases the capability of nuclear weapons. So, I mean, do you predict that we're going to see more nuclear facilities globally, as long as they're not stepping on that political issue of potentially making weapons?
Sorry, my cat's putting her butt on camera. She used to being a Zoom star, and I haven't been on much Zoom lately. So, but yeah, I do see more coming internationally. I think one of the things is when you see kind of like the pushback against the no weapons stuff, is that there is a very, very small very difficult way to create weapons. So I think of it thorium. So thorium example is that thorium will create a very, very small amounts of protactinium, which can be used to be made bombs. But the way as I go about explaining it is, like imagine if you had to get $100 and you had to like $100 worth of pennies, but they're all shattered into 4 pieces and you have to solder all the pennies together. That would be like making a bomb from like a thorium reactor. So very difficult. From the TRISO stuff, I don't know how you can make a traditional weapon. You could probably make a dirty bomb of some account. I know DoD was worried about that in case like they said like, oh, if you're flying in a reactor, if the plane gets shot down and someone goes and collects the bits, what can you do with it? So you can't make, say, a nuclear weapon that as we traditionally think of it, but you can make something potentially, but I don't know what. But there is planned for like a kind of a regulation, a global regulation as we do, especially as it's first emerging. For some of it, it is just kind of like our nuclear energy apparatus is tied in directly with like nuclear weapons. So they're kind of in that constant communication. So there'd have to be some level of kind of global regulation, national regulation on each state's level as to like where it's going. But if you look at like the countries that are developing it, India, China, these are kind of like nuclear capable countries. So I think we'll see it in these places first before we see it move into, say, non-nuclear countries. But I think it will eventually get there. One of the things I've also give like a type of this presentation to an energy policy class. And I kind of always on that like foreign section, I always point as like Africa as a big kind of opportunity for these small modular reactors, because a lot of them be like, you can put them on a shipping container, ship them halfway around the world, plug them in, turn them on, there isn't a ton of risk. That I think that'll be kind of the big market because there aren't really nuclear capabilities across most of Africa. But there could be this huge energy upside bringing in these things. So I think that'll be the first kind of big non-nuclear nuclear weapons power bringing in nuclear energy would be somewhere across that continent.
Thank you. Other questions? Okay.
There's a link in the chat to the presentation on coal that he mentioned. Maybe Dr. Jackhead or Brian, if you want to explain that a little better.
I'll give it a shot. So in Hopkins Hall Art Gallery, which is on the Oval on campus, we have a art exhibition essentially of fine arts photography, historical documents, historical artifacts, and some more current photography that just sort of explores the transition away from coal in 3 case study communities. We have 3 case studies that have been published, or we're sort of in the process of publishing them. That'll be published through Extension that looks at the coal transition in Belmont, Noble, and Coshocton counties. We have lots of cool stuff, especially from Coshocton, including old mining equipment and mine maps from the underground mines in Coshocton, and all sorts of good stuff. And it turned out, the exhibition I think turned out pretty well, and it's pretty, it's turned out pretty, and it's fun to look at and explore. We also have we teamed up with the Department of Theater, and we have 2 theater professors who reenacted some of our interviews with key informants. And so these actors are sort of reading verbatim the interview scripts, and so you can listen to some of those interview excerpts in the art gallery. And so that's going to be up in Hopkins Hall Gallery until September 16th. And it's Monday through Friday from 11 to 4. However, if you want to visit the gallery after or before those hours or on the weekend, just let me or Brian know, and we can get you in for a private tour. And there's also a sort of a complimentary exhibit going on at Thompson Library on the Oval, where they're displaying sort of old historical documents that the library has related to coal, including some stuff from like the 1850s and the 1860s. Is pretty interesting. There's a map from the 1700s on display. And that's going to be up until February. But and the hope is that that this exhibit will move online after it's done in Hopkins Hall, and so there'll be an online resource, and that some of this material will be exhibited in our 3 case study communities. So and as Brian mentioned, we have postcards. There'd be no art exhibit, would not be complete without postcards. So get your collector's set from the Hopkins Hall Gallery.
All right, thank you. Here, I'm going to go ahead and stop the recording now. Brian, thank you for the presentation. That was really informative and really interesting. I got a good perspective on nuclear now that I didn't have before.
Thanks for having me. Sorry, I go off on a ramble whenever I talk about this. At least there was a semi-organized structure when I talk about this other people. It's just like, and another thing. But thanks for having me.
Thank you. Right. So I'm going to